Hello all. Today I'll be solving one of the questions along with a variant that is most frequently asked questions for meta interviews. I'll try to finish this in about 15 to 20 minutes with the variant, dry run, um, edge cases, and also anything like code cleanup and stuff. All right, so I'm gonna be pasting my question, and once the question is pasted, I'm gonna start the timer for like 20 minutes. All right, here's the question. Let's start the time. Actually, timer for 20 minutes. All right, so the question given is given an array of integers of numbers, find the next permutation of the numbers. So my questions, so input is a list, an array of integers. So it could be 1, 2, 3. All right. The next permutation of the number. So permutation is use all the elements in any order. In any order. Um, Here, edge cases. Do I only digits? Also, next permutation. And the other thing I'd worry about is the length of the area. And yeah, so did yes, there will only be digits. Also, for the next permutation, it's it should be bigger than the current number. Okay. And length can go up to 100. 200. Okay. Hmm. So for this input, if suppose it's 1, 2, 3, the output, would it be like a list of strings? Yes. So, sorry, list of numbers. Yeah. So the next number that is 123, right? So the next permutation would be in 132. Think that should be the correct answer. Yeah. Okay. So if it is permutation, one way like would be to generate all. So suppose right now there are three elements. That means there is 3 factorial possibilities. And then just find the next permutation. So for example, this is 123, 132, 1, so 231, and I think it should be 2 1, 2 1 3, 3 1 2, and 3 2 1. So if suppose 231 was given, then we could just go all over the array, like we can just store it here and then return this one. So the total time complexity would be O of n factorial to generate all the permutations into O of n, which is like however many possibilities that we go over in this. It's kind of a brute force approach. We can optimize this. So from what I understand, like let's say we have an example which is maybe 1, 3, it's 1, 2, 4, 5, 2, 1, right? And right now we see that the number we need should be bigger than this, and also we understand that if we check from here, because units, tens, hundreds, thousands, and so on, so we can change initially here to make a bigger number, right? Before changing all the way up here, because we need like just the next biggest element. So next biggest number. So one idea could be to like start here and keep on like going back and forth, and we realize that like if it's already in 5 to 1. Oh, one edge case that I forgot to ask is what if the number is the biggest number? For example, what if it was 3 to 1? Now we know this cannot like have like bigger number. So I guess the interview could just say do it 1, 2, 3 as the answer. That is just reverse the string, reverse the numbers. Okay, so here we back to this, as this is similar to this edge case, right? So if we have 5 to 1, then we know that this number cannot get bigger from this point. Then we come here and we see now there is some possibility to change this. So if we need a bigger number, 1, 2, we need a bigger number than this. So let's say we have 5 and 4, 2, and 1. So we know again this becomes a decreasing order, and this should be the next permutation. Should it? Mm, maybe not. It should be actually 1, 2, 5, 4, 1, and 2. So this is like this would come right after this one. It's, right. So this should be the answer for this situation. So initially, what I can optimize, like write it as an algorithm, is to find a pivot point, which is nothing but the when the monotony, like the sequence breaks. When so let's say if this was I, to find the pivot point, which would be I is less than I plus 1. Yeah, and we will keep on going backwards. I plus minus 1. And then here, when we found that, we swap the index here. So for example, when this was the case, we did 1, 2, 2, 1 already existed. And then, no, we swap it with the last smallest element. So we had 1, 2, 4, 5, 2, and 1. Now we will, I think I did it wrong. So now this is the smallest, the 1, and then we oh no, we have to swap it with the element that would make it bigger, because if we swap it with like any element that is smaller than this 4, then it would just make the number smaller. So we do 1, 2. We find it from this side because we know that everything in this side would be if one element is bigger than that. So we do 1, 2, 5, 4, 2, and 1. Now we know that this is the answer. So swap the element with a slightly bigger number, not a lot bigger number. For example, like if there was a 7 here, could have done the swapping, right, with 7, but then we would not do that because that would make the number significantly bigger. So that's why we do it with like just a slightly bigger number. The first bigger number, because everything from here down is like a number in the decreasing order. Okay, and third, we just reverse the rest of the array. So if we did this swapping, we just reverse from like this one. Let me 10 minutes. Okay, so 10 minutes to write the code and also to do the try run. So divine next permutation. We are gonna get a list of integers, and the answer is also the list of integers. From typing import list. All right. So first we find the pivot, and we'll start from the left side. So let's say our pivot point is equal to, let's just get the length. Oh, we also need to define the name. Let's just do array. Array is equal to length of array, array length, pivot. So pivot is, we know that like if we start here, that there's no element in front of it, so we could just start from n minus 2 n minus 2. Yeah, and so for actually while pivot is greater than or equal to 0, we'll do pivot minus equals 1. Now if array at pivot is less than, yeah, array at pivot I plus 1, pivot plus 1, right? So we have to find decreasing one. So this number should always be bigger or equal to. Then we break. That would be our pivot point. I mean, we don't necessarily have to break. Or we could just put this in the while condition so we know where the pivot is at the end. Okay. And, okay. Now this is good enough. We keep on going until we find the pivot point. Now, one edge case would be already decreasing numbers. Decreasing number. If pivot equals to -1, then we do return reverse array. That's just return that array, reverse it and return it. This would do it in place. I think that is what the function is. And also, I forgot to ask earlier, do we create a new array or do we need output new array or in place? Let's do in place for now. Yeah. And then we will Already found, done the edge case, found the pivot. We swap the element, So we will go if pivot is greater than or equal to 0. That is like it's not, there exists a pivot. And we can just initialize like maybe swap pointer and -1. That would be at the end of the array. And we'll do while num array at I swap pointer. So this number needs to be smaller than or equal to the array at the pivot. We will decrement this pointer, swap pointer minus equals 1. And then we'll do the exchange. So array at swap pointer and array at pivot is equal to array at pivot and array at swap pointer. And then now we just reverse from pivot plus 1 till n minus 1. Yep. So we could just do left is equal to pivot plus 1 because that is where we will start the, and this would be n minus 1, that is array length minus 1. Array length minus 1. And that would be right. While left is less than right, array left, array right, equals to array right and array left. Also decrement the pointer. So left plus equals 1 and right minus equals 1. Okay. We only have like 3 minutes, so let's just do the dry run quickly. Array length. Segment this is good enough. Length of the array, this would be array of length minus 1. Alright, so let's say we are doing this 1, 2, 4, 5 to 1. So we can imagine array is this. And array length would be 1, 2, 3, 4, 5, 6. Alright, pivot would be array of length -2 because we want to start at this position. So the pivot would start at 2. Now we'll check this condition. So while right now pivot is greater than, like, no, this is 6 minus 2, 4. 0, 1, 2, 3, 4. Yeah, yes. And here we check it's greater than 0. Yes, and this currently 2 is greater than +1, pivot +1, that is at 5th index. So yes, correct. Then we decrement the pivot, which goes down to 3. Now the pivot is at, this would not execute. So right now the pivot is at 5. Then we'll check this condition again. This is greater than 0, correct. Now 5 is greater than 2, so we're good. Then we decrement the pivot. Now the pivot goes down to 2. So now here we check again. This is not greater than, less than, like 4 is greater than 2 is greater than 0, and this pivot would be not true because 4 is less than 5 is not greater than 5. So our pivot point becomes 2. We don't decrement it. And the while loop ends here. Now this case would not execute and we go down. And if pivot is greater than or equal to 0, which is correct because it's true, we are at swap pointer. I put in on my array of length -1. So our swap pointer would be at 1. That is like the index, right? So 0, 1, 2, 3, 4, index 5. And then it's just basically 6 minus 5 here, which is equal to 1. Okay, that's where we start. Wow, dry run would take some time more. 20 minutes was clearly not good, but I'll just keep going so I can finish it in the next 5 minutes and then we go again. All right, so while array at swap pointer, so which is at 1. So 1 is less than or equal to array at pivot. Array at pivot was at 2, which is 4. That is correct. So we have to decrement the swap pointer and we will go down to, my gosh, 6 minus 1 is 5. So we go down to 4. So now the swap pointer is at 4. Now we don't do it because right now this is true. While this condition is true, we will keep on decrementing. So now it's at 2, which is also less than 4. So this would not increase the number. So we go like at index 3. Now we are at 5, and that is not less than or equal to 4. So we break up. And here we do the swapping, which will be 1, 2, 4. So array at swap pointer, what is that? 0, 1, 2, 3, 5. And we will do it with this 4. So this would become 5 and this would become 4. This is the array that we have right now, and then our pivot pointer left, which was at 5 plus, so 1 pivot is at 2 plus 1. So this will give 2 plus 1, and our array length -1, which is 5. So we are at index 3 and 5. 0, 1, 2, 3. So from here to here, we'll go on to swap. So here, left is less than right, correct. Our left pointer was at 3, which is 4. And here, this part would remain. No, only this would change. So here, first swap, we'll do 1 here and 4 here. This is what this will do. And then our left will decrement to, will increase to 4 and right will decrement to 5. Now it's all sorted, but again, this will try to do it this swap again. We'll increase the left 5, and if we decrement it, we will out of while loop, and that is done. I think this is all. And the variation of this problem is find the previous permutation. So if this is our example that we take again, so I have like about 1 minute remaining. I'm gonna like just increase it by another 5 minutes. So I can just go over this quickly, at least not through the code and the dry run, but you'll see. So, okay, find the previous permutation, which is this, and then we have to find 1, 2, 4, 5, 2, 1. Okay, the number, if it's a previous permutation, the number needs to be smaller. Needs to be smaller. So again, this case where 5 to 1, we know that like this number cannot be made, like can be made smaller. And the pivot point here should be the opposite of this. So instead of checking when this condition breaks, where did it go? Here. Wow. Command. Same. So let's say we have this condition here, and our pivot starts here. And we have to check if this is greater. Yes, this should become less than or equal to. So is 2 less than or equal to 1? No. So pivot. And this would be 1, 2, or 1, 2, 4, 5. And we just swap with this element. Right now there is no extra, so this would become 1 and 2, which is technically the next previous permutation. So if I take like a different example, let's say if the example was 2, 5, 4, 3, 2. Actually, maybe if the example was, let's think of a better example. So if it is 2, 1, 3, right? So we need a number smaller than this, smaller number. So in this earlier example, 2, 1, 3. So 1, 3, 2 would be the answer here. 1, 3, 2. And what we'll do is we'll go from here. We'll check this condition. Is 1 greater than 1, less than equal to 3? Yes. But then is 2 less than equal to 1 when this comes? So this condition starts here, but now when it comes, this is the pivot point. 2 becomes the pivot point, and what we do is we replace it with the smaller element. So we'll go over 3. Is 3 bigger than 2? Yes. So we, in the next run, we'll check this condition. Now we will do is we'll swap this, and this becomes like the answer. No, this would not become because we need 1, 3, 2, and then we'll reverse the rest of the string. Now, like because we know that 1 is in the right place, so it would be 1, 3, and 2. And that's the answer. Okay, thanks for watching. Bye.